Welcome back to the deep dive. We've sifted through 24 different sources for you this week. It's quite a stack: hardware, science, policy.
A real mix.
Yeah, and our mission, as always, is to cut through that noise and give you the essential insights you actually need.
And looking through it all, one theme really jumps out, I think. It's this intersection of, well, power and responsibility.
That's a good way to put it.
Yeah, the pattern seems to be reasoning is getting stronger at the core, in the models themselves. We're getting much better tools out at the edge.
Right.
But there's also this quieter but really urgent focus now on making sure everything's reliable.
Yeah.
And controllable.
Exactly. So let's distill what's actually changed, why it matters for, your strategy, and what you should keep an eye on next. Maybe start with the pure physics, because compute seems to be going in two directions at once.
It really does. Huge scale-ups and, at the same time, shrinking down.
It's kind of a wild duality, like an arms race on two fronts.
Precisely. Very different economic pressures driving each one.
Okay, let's hit the big scale first. The central power play. We're calling it the gigawatt bet.
Right.
OpenAI and Broadcom. They've confirmed this multi-year plan, 2026 to 2029.
Yeah.
Shipping custom OpenAI-designed AI accelerators. They're on silicon, basically.
Yeah.
And built on these Ethernet-first racks.
It's a massive commitment, but the scale, it's measured in gigawatts. People are talking about a 10-gigawatt investment.
Wow.
And the why behind it is fascinating. It's economics, really. They're shifting the supply chain, calling it a house blend.
House blend. Meaning?
They're folding what they learned from training and running their models directly into their chip designs. Tailor-made silicon.
Okay, to the practicality check. What's the real impact of a 10-gigawatt commitment? What does that mean if you're, say, a practitioner or an investor?
Well, it tells you custom silicon isn't just nice to have anymore. It's basically table stakes for anyone serious about frontier AI.
The cost of entry just went astronomical.
Borderline impossible, yeah, unless you have, nation-state level funding or OpenAI's kind of scale. And the driver, it's inference.
Using the models, not just training them.
Exactly. That usage is just exploding. If you don't control your own hardware stack, the cost will kill you or at least slow you down dramatically. So they have to become their own hardware vendors, essentially.
So the giants are building these, compute fortresses.
Mm-hmm.
But at the exact same time, high-end AI work is getting
physically small, yeah. It's an incredible contrast. Which brings us to the other end of things. The desktop petaflop.
Right, the decentralization story.
And this is a real aha moment for local compute, I think. NVIDIA's DGX Spark. It just landed at SpaceX.
And this thing delivers, what was it?
1 petaflop at FP4 in a single desktop unit.
Whoa, hang on. 1 petaflop on a desk?
Yeah.
And FP4, can you translate that a bit? Why is that format such a revolution?
Sure. FP4 is just a data format, 4-bit floating point. It's super efficient for calculations, especially inference. So, using their new GB10 Grace Blackwell superchip, this box can do incredibly fast calculations. This isn't some hobbyist toy. We're talking serious AI work, fine-tuning models up to 200 billion parameters.
So models that usually needed a massive data center queue are now, carry-on size?
Pretty much. It massively shrinks that build, measure, learn loop for development.
That seems huge.
It is. It's like a lab in a box. Think about robotics teams, specialized engineering groups, maybe even high-end VFX artists. They can iterate top-tier stuff locally. No more waiting for data center time, less overhead.
Okay, that's definitely powerful. But isn't a desktop petaflop, even if it's small, still, out of reach for most? You need the specialist engineers, the $50,000 budget for the box itself?
That's a fair point.
Isn't cloud access still the main way AI gets democratized for the average developer?
Yeah, that's the critical tension, isn't it? Cloud democratizes using the models, for sure. But something like the DGX Spark, it democratizes development, but specifically for those well-funded cutting-edge teams.
Oh, okay.
It speeds them up, makes them less reliant on the big centralized clouds. The very resources OpenAI is sort of consolidating with its gigawatt bet.
That really sets the stage. Petaflops on the desk, gigawatts in the cloud. So where's all this incredible compute power actually going? Turns out, some really big problems.
Yeah, problems humanity's been chipping away at for ages. Fusion energy, cancer.
Let's start with fusion. AI is a real-time pilot, you said.
Exactly. Not just predicting things after the fact. Look at Google's Fusion team. They're embedding AI right into the life cycle of the Spark tokamak using a tool called Thorax.
Thorax, tell us more.
Okay, so TORX is a plasma simulator. It's fast, built in JAX, which means it's differentiable. That's key.
Differentiable meaning.
Meaning you can easily calculate how changes in inputs affect the outputs. So they're using reinforcement learning AI training through trial and error to explore how to run the plasma for higher energy yield. And, crucially, how to manage the intense heat exhaust in real time.
So it's not just about if fusion can work someday, but how to make it work practically.
That's the goal. Shorten the road from just getting that first plasma burn to actually generating useful power. AI becomes the pilot, essentially, optimizing the physics on the fly. It could compress decades of traditional trial and error engineering.
And that same pattern, optimizing complex systems, jumps right over to biology. Heating cold tumors.
Yeah, it's fascinating. DeepMind and Yale, they used a model called Gemma C2S-Scale 27B.
Okay.
And it predicted a specific two-drug combination that seems to make cold tumors, the ones that hide from the immune system, more visible. It boosts antigen presentation.
Now, the model they used, 27B, that's big, but maybe not the absolute biggest out there. Does the size matter here?
Well, that's actually the interesting part. It shows you don't always need the monster trillion parameter model. This 27 billion parameter model, while decent-sized, was specialized enough.
Right.
It spotted this subtle contextual link between a CK2 inhibitor drug, silmatassertib, and low-dose interferon. And the prediction moves straight from the computer simulation, the in silico part, to being confirmed in lab tests, in vitro, very cleanly. It really suggests that biology, maybe like language, follows certain scaling laws.
Yeah.
You need a sufficiently large model to catch those complex hidden relationships that older methods would just miss.
Okay, taking that predictive power down to the individual level. Predictive healthcare rolling out now in Abu Dhabi.
Yeah, this is a really interesting case study, especially for integrated health systems. They've rolled out an AI-powered risk profile across all their clinics.
Saving doctors.
Personalized probability scores for about 14 different conditions. And it's all grounded in the resident's Malafi.
Malafi, that's their unified health record system, right? From birth.
Exactly. An incredibly deep data set for each person.
Yeah.
So the AI can potentially spot risks much earlier, enabling smarter referrals. And they seem to be thinking carefully about the rollout.
How so? Like, who makes the final call? Is the AI in charge?
No, definitely not. The doctor is still firmly in charge. The AI score is an assistive tool. And importantly, they have two LLMs involved. One helps the clinician make sense of the record quickly, and a second one is built into a patient app. Its job is to explain the risk profile and the doctor's recommendations in plain, simple language. So it's focused on support and understanding, not just AI saying, do this.
That focus on making AI practically useful flows right into our next section. Productivity and creative control. The big idea here seems to be specialization.
Taking that general AI smartness and packaging it for specific tasks.
Right, which brings us to Anthropic's new thing, Claude Skills.
Yeah, these are like portable folders. You bundle instructions, maybe some code snippets, reference documents.
So you package up the knowledge needed for a specific job.
Precisely. Claude can then load just that skill, say, for drafting according to specific brand guidelines or following a complex compliance checklist or even using a particular coding standard. It makes the general AI into an on-demand specialist.
Repeatable, governable workflows.
Exactly. And related to that, on the enterprise side, there's the Claude Microsoft 365 integration.
The search thing.
Right. Unifying search across SharePoint, OneDrive, Outlook, Teams, pulling info together from all those silos and giving you grounded, cited answers. It feels overdue, honestly. Good co-pilots need to live where you actually do your work.
And when you make knowledge work more repeatable, more efficient, well, there are bottom line consequences.
Yeah.
Which takes us to Goldman Sachs.
Yeah, the automation versus productivity cost calculation. Goldman is actively constraining headcount growth, even cutting some roles.
Why now?
It's tied to their big digitization push, OneGS 3.0.
Yeah.
It's transforming workflows in areas like syndicated lending, regulatory reporting, even vendor management. This isn't hype anymore. AI adoption is showing up on spreadsheets.
Okay, let's dig into that. What's the actual metric? What efficiency gains are driving these job decisions?
It really comes down to cycle time reduction. Sources are saying that some of their internal AI tools are drastically cutting the time needed for things like generating complex lending reports.
From weeks to days kind of thing.
Something like that, yeah. Tasks that involved a lot of manual data gathering and review are getting much faster, so they're reorganizing around that productivity, leaner, faster operations. The headcount constraint just reflects that the ROI from these tools is real now, measured in saved time and money.
Okay, Shifting from spreadsheets to storyboards, creative control. Video tools got a boost this week. Sora 2, VO 3.1.
Yeah, Sora 2 added editable storyboards, which is a big step towards actual control, and unlocked longer 25-second clips for pro users. VO 3.1 brought in native audio huge and seems better at actually following the prompt.
So less like winning the lottery with a prompt.
Exactly, moving towards more of a director's console feel. Control, consistency, editing the flow, that's the direction.
But maybe the most inventive little discovery wasn't a whole new tool, but a trick for existing LLMs.
Right, a fix for that feeling you sometimes get where LMs feel boring. Derivative, it's called typicality bias.
Where they just give you the most common average answer?
Pretty much. They favor familiar text patterns, but there's this simple training-free trick called verbalized sampling.
Okay, how does it work?
Instead of just asking for, say, a story idea, you preface it. You ask the model to first, quote, generate 5 diverse candidates with their probabilities.
Just adding that phrase.
Just adding that phrase. It forces the model to explore more of its potential outputs, not just the most probable one, the result. It basically doubles the diversity of the output, often without hurting the quality or accuracy.
That's clever.
It really is. It shows these small tweaks at inference time when you're using the model can unlock creativity that's already there, just dormant. Makes them feel inventive again.
That's definitely something anyone listening can try out immediately. Okay, final section. The control tower. Responsibility, regulation. Looks like the industry is feeling the pressure.
It really has to, especially when kids are involved. California's SB 223 stands out here. A new law making operators of companion chatbots legally accountable for youth safety.
Accountable how? What does the law actually demand?
It forces them to move beyond vague ethical guidelines. We're talking measurable, auditable stuff. Mandatory age alerts, clear disclosures about suitability, and actual crisis protocols.
Like for suicidal ideation.
Exactly. Real-time intervention steps, not just buried terms of service. It shifts the burden significantly from the user onto the provider.
And at the same time, the industry is grappling with how to treat adults, like adults, safely.
Right. OpenAI, for instance, planning to relax rules on adult content, allowing erotica, but only for age-verified adults, starting in December.
So tricky.
Very tricky. It has to come with really robust age gating, expanded safety systems. They've set up this new well-being council to guide it. You need serious verification tech and solid crisis management if you're going down that road. Protect kids, but allow consensual adult content. It's a difficult balance.
And then there's the misuse side. Our last item is pretty grim, actually, this AI homeless intruder prank. Police are warning people to stop.
It's just awful, utterly reckless and dehumanizing. People using AI image generators to create pictures of, like, an intruder inside someone's house.
And then texting it to relatives.
Yeah, triggering fake 911 calls, wasting critical emergency resources. It's incredibly dangerous.
Police are pointing out rightly that responding to what they think is a live, armed intruder situation, things can escalate dangerously fast for everyone.
It's a stark reminder of how powerful tools can be twisted for, frankly, malicious and stupid ends. And often the solution isn't more tech, it's basic human sense. Pause, call to verify. Responsibility matters just as much as capability.
So wrapping this all up, looking back at everything we discussed, what are the two big, maybe conflicting forces you see shaping where AI goes next?
Two main forces. First, I'd say reasoning rises. We saw it in the drug discovery, the fusion planning models. The core AI is getting fundamentally better at planning and understanding context.
Okay, reasoning up.
Second, compute constraints. That 10-gigawatt bet by OpenAI makes it obvious. The need for efficiency, like that FP4 desktop chip. The physical limits of power, silicon, and cost are absolutely shaping the pace and direction of development.
Got it. Reasoning rises, compute constraints. Now, for you, the listener, especially if you use LLMs day to day, one practical takeaway from this deep dive. Try verbalized sampling.
Yeah, that little trick.
Next time you need creative output, just ask the model first.
Yeah.
Generate 5 diverse candidates with their probabilities. See if it breaks that typicality bias and gives you something less generic.
And maybe one final thought to leave you with. We talked about Goldman Sachs, efficiency, layoffs, and that huge gigawatt data center investment. But we also need to remember the other side of the AI labor coin. Meaning the massive growth of human-in-the-loop work. Data labeling, transcription, quality control, often done by large teams in places sometimes called cloud farms, maybe in rural areas globally. This essential, scalable human workforce feeds the AI systems.
So AI isn't just taking jobs, it's creating this whole new category of AI support jobs.
Exactly. It's
Yeah.
reshaping labor markets in complex ways. So the question to mull over is, where will the bulk of capital and attention really go in the next 5 years? Will it be the race to AGI and the custom silicon frontier? Or will it be scaling and managing that essential human loop that actually makes the current generation of AI work reliably? Which side of that equation will dominate? Something to keep thinking about.